Hey guys, welcome back to another episode of Simuleos. Today we're going to continue working on what we were working on yesterday, the Huffman trees. Now, if you remember, we had some trouble at the very end there, getting the Huffman trees to work out the way we wanted them to work out. I don't even remember how much code we actually wrote yesterday, but that's okay, because today we're going to get back to it, and we are going to continue working on them, and I have an idea as to how we can make them look a little bit cleaner. I went through a guide that Gustorn posted a while ago. I got an idea that I wanted to try out, so that's what we're going to do today. Unfortunately, it's probably more just visualization today. Hey Gustorn, so I guess maybe we aren't yet doing the Vitter algorithm or dynamic Huffman encoding or any of that kind of stuff. We've got a lot of stuff to get done. So let's go ahead and CD into the appropriate directory, and then we'll open up Zernal and talk a little bit about what the plan is for today. So let's CD into projects, Simuleos, and Huffman. Same thing over here, CD projects, Simuleos, and Huffman. Now we're going to open up Zernal and let's talk a little bit. Okay, so here's the idea. We've discussed Huffman encoding a few times now. The idea is, of course, that we have a string. Any string will do, so we'll say hello. That's our string. And there's some sort of frequency for which the word hello, or every letter in the word hello, appears. So H, for example, appears 1/5 of the time. L appears 2/5 of the time. So let's just draw that out. L comes in with a frequency of 0.4. Sorry about the yawn, guys. H comes in with a frequency of 0.2. E comes in with a frequency of 0.2. And O comes in with a frequency of 0.2. We add together the two lows to make 0.4. The two lows again to make 0.4. I'm sorry, 0.6. And then the two lows one more time to make 1. We go back down the tree and say that one path is 1, the other path is 0. And then we say L is simply going to be 1. H is going to be 0, 1. E is going to be 0, 0, 1. And O is going to be 0, 0, 0. And there you have it. We have turned our word into an encoded word that we can now read out. So it's going to be H, so 0, 1, E, 0, 0, 1, L, 0, 1, 1, O, 0, 0, 0. And there you go. That is our encoded word. Okay, so this is pretty straightforward, I think, based on what we've been doing recently. Of course, if you have any questions, let me know and I'll totally get to that when we have questions. Now, new page before. What are we doing right now? Right now we're visualizing Huffman trees. And honestly, I thought this would take a day. It's taken like 2, maybe 3 days so far, and I'm still not content with what it looks like. So we've got a little bit left to do here. The first thing we tried was the following. We start with some sort of root node, which is right here. And then we say, okay, well, let's move the next node over here and over there. So this over here is precisely at 0.25, and this one's at 0.75. Okay, and then we do, okay, well, let's add and subtract another half over here and another half over here. And for a while, we kept doing that. We kept saying, okay, well, now we'll add another half here, another half here, another half here, another half here. So that here we're adding and subtracting. So from here to here, we're adding and subtracting 0.25. From here to here, we're adding and subtracting 0.125. From here to here, we're adding and subtracting 0.6. Is it 625? 6225? 6125? Is that right? No. 60. Wait, I'm really bad at this. Okay. 0.0625. You multiply that by 2, what do you get? You get 125. There we go. So on and so forth. So we keep taking this initial value, which we'll call V, is equal to 0.25. And every single one of these guys, we take the value and we divide that by 2. So V over 2 every single time. And that's the idea, right? And this does make a good looking tree. However, it's not very easy to read because every once in a while we have letters that are overwritten. As in some of these, when we get super far down, some of the dots are actually right next to each other. And so if we have dots that are this size, when we get down here, all of a sudden the dots are like right here on top of each other. And there's really not much that we can do. 0.625. Is that right? Oh, you're right. You're right. There's another 0 in here. My bad, guys. That's me not able to do math. Okay. I don't know why. I knew it was 625. Anyway, that's fine. It's okay, Gaston. Don't worry about it at all. Okay, so this was one visualization pattern that we have in the bag, but let's talk about another one. New page before. Here's what we're going to do. We have the alphabet size. Alphabet. Which is the number of letters used. 1 second. So, we have that. It's the number of letters used. And so here's the idea. What if instead of... 2 minutes quite large. What if instead of using, let's say, a static location, not static, a dynamic location like we did before, what if we give these guys a static location? So let's say the alphabet size is 5, then we say 1, 2, 3, 4. We give 5 potential slots, and we put 1 letter in each slot. So all letters have equal representation. They all have equal delay, or equal, how do I put this? Equal distance between each other. Hey, H226, how are you? Nisimico, what is the best programming language? My friend told me to learn a modern object-oriented language like Pascal or QBasic. So the problem is there isn't really an answer to this question. What is the best programming language kind of comes down to a lot of different things between personal preference and your own project that you're working on, right? Good, I'm glad, Edge226. I don't remember if I asked, but I hope I did. Okay, what is the best programming language? Yes, so this is related to your own personal preference and things like that. So I would say find a project you want to work on and learn the programming language that's necessary for that. Good general programming languages, yeah, that's totally important. I love Twitch. So it depends on what you want. For the best general programming languages, I typically tell people to try to do C++ or something like that, just because it's used all over. But again, it's totally up to you. If you need to learn a modern object-oriented language, I don't know. I don't really have the best advice here. Some people in chat though probably have a good idea of what you need to learn. So I'll keep an eye out and remember that answer for the next person who asks. Okay, so here's the idea. Since we have the alphabet size, we can actually place each of these guys at a very particular location. And this area would be 0.1, 0.3, 0.5, 0.7, and 0.9. 10 times. Okay, so the Y position here doesn't really matter, but what's interesting about this is that we can put the internal nodes at exactly halfway between these guys, and those internal nodes will be exactly halfway between those guys, making a tree that looks absolutely fantastic. Just nice, crisp, and clean, and that's what we want to do. So this is the first thing I'm going to try today, giving each of the each of the gosh darn it, letters in our alphabet some static location along X, and then we'll worry about it from there. Hey Zivo, what's up? Okay, so this is what we're going to try. But C++ can be especially abstract and thus difficult to understand someone else's codes if they do not want to be understood. Never like Golang, even though it has its merits. Yeah, I've never used Golang, honestly. I don't know. I remember I asked someone about it, and they seemed to appreciate Go, but I didn't know why people would use it. I don't understand its advantages over other languages. Like, for me, Julia is its competitor, but I don't know who else is competing with it. Okay, so this is basically the idea, right? We're going to take our Huffman tree and we're going to try to give static X locations for each of the leaves. And we're going to see how this turns out. I've got a feeling that it'll turn out a little bit better than the one that we currently have, but not perfect. There's going to be some issue. And I've got a feeling I know what this issue is going to be, but That's okay. I've never used a makefile, and today I had my hands on it on Linux. Is any way to run it on Windows? I hate CMake. I'm actually not sure. I figure makefile, yeah, Cygwin would be what I would suggest. If you want a modern system programming language, Rust is interesting. C++ still has is a king in high performance. Yeah, sure. If you want to get some nice results quickly, you can try Python. Yeah, that's basically the same suggestions I would give, honestly. Between C++ and Python, I don't find myself using many other languages. I mean, I use Julia and Fortran, but come on. Okay, so let's show what the animation looks like right now. So we do Mirage, frames, animation.gif. Here's what we currently have. And while that's running, I now remember we screwed with it. While that's running, I'm going to get a quick sip of water, and then we're going to remake this so it has a little bit of a different appearance. Let me see. It's made to be a concurrent language, and that's mostly what I find interesting about it. Sometimes something with more freedom, of return types and such is what I think is cool about it. Being able to say return string and return number and such. I find the lifetimes and guarantees of Rust way more interesting than Go routines. Yeah, I'm not sure. Again, I've never used Rust or Go. Maybe I should try. But anyway, you guys clearly saw some things wrong with this particular, this simulation here. Let's go through and let's fix some of the stuff here. So let me go into the Huffman visualization.cpp. Let's go down to the bottom, and there should be draw tree. Here we are. This is where I give all of the orbs, all of the balls, some sort of size. So let me go through and let's give them all an appropriate size here. So instead of this guy here, which I agree we need some sort of dynamic way to do this, let's go back to our static size, and then we'll go from there. So let's do, I don't remember what the size is right now, but I can imagine 100 is too big, so let's just say 10. Add a space there, write this, go over here, and let's run the make command. 1 second, make. Okay, once it's made, we should have an image. Now, I don't remember how big this image is. I think it's 400 by 300, but let's see just to make sure. It looks like that was incorrect. Are we not making the animation? Oh, we're not making the animation. Let's go to the make file. Now let's go down to the convert thing here, and let's write and quit. Man, I'm so just make clean, make. Okay, give it a second to make and make the image, and then we should be good to go from there. Let me see. And then we're gonna go ahead and try some different things here and there. Okay. So let's go ahead and do Mirage animation.gif. There we go. So this one looks a little bit better in that we can actually see all of the letters. However, again, this highlights the next issue that we had before. So let's scroll down, look at these letters, and you'll notice that some of these letters are clearly appearing over other letters. So for example, if we look down here, there is now a dot there and another dot right there. They're literally right on top of each other. In fact, there could be 3 there. Let me see. So I guess I move over here. Oh, where is it? Hello? Ah, there we are. Okay, so these letters are on top of each other. These letters are on top of each other. There's a lot of things to do for now. So let's keep working on this. The first thing we need to do is go into the Huffman tree, which is the, how do I put it? The struct in which we keep all the stuff for the Huffman tree, and we need to go in there and we need to add in one additional element, which is the alphabet size. Now, that said, I think alphabet's the right word. I might be wrong here, but I think it is. So let me go back up to the GIF, so we just have that playing on the side, and then at that point, we'll continue working. What did I miss? Edge 226 visualization. Oh, I love Twitch. Thanks. We worked pretty hard on this visualization, so it's been kind of going slow. This is actually the first time I've ever done animation of this type with just Cairo, so I'm pretty happy with it actually. Let's see. Rust catches a lot of memory-related errors, compile time without runtime costs, iterated invalidation used after free. all the stuff that I don't know very much about. It's a very interesting type system. I don't know. I've never used Rust or Go. Maybe I should try. This is the discussion between Rust and Go, right? Am I missing something? Okay, good. So let's go here and let's move into, let's see, vi huffman.h. Okay, now what do we need to do? We need to go down here, huffman.h, and let's see. We should have Huffman tree right here. So let's do the following. Let's do int. Actually, what do we want here? We already have an unordered map with all of the strings in them and all of the bit strings. So basically we say, hey, A is 01, B is 001. That's what the bitmap is up there. We have the encoded phrase, we have the weight map. I think all we really need is the library size. So let's go down or the alphabet size. So I'm going to say alphabet size. I know it's kind of long, but that's okay. That requires a lot of resources. I'm thinking about making visualization sorting algorithm. What graphic library do you recommend? Honestly, I don't know, Zivo. I really don't. I chose Cairo because I actually wanted to draw a webcomic with code, and then I've gotten to like it for a bunch of different things. If you want to do animations though, Cairo is a little bit rough. We had to go through and do a whole bunch of random things to make it work. And even so, it's still finicky, in my opinion. Like, so for example, this is what we had to do to get this to work. So let's go into vi huffman visualization .cpp. Okay, so first of all, we have this struct frame, and frame is used for basically holding all of our animation data. So you'll see in here we have, let's see, color surface t frame num surfaces. So we have the number frame of frame surfaces here, and we have frame context here. I mean, I remember I'm working a framework to build Linux distros. I compile a heck of a lot of software at times. Fair enough. Yeah, so I'm with Gustron here advising against Cairo for this. That said, I like it. It's kind of fun. Anyway, so what we did to get this to work, and this is kind of just a recap in a way. In order to get Cairo to work, it has 3 different layers. It's got a top layer, which is known as the source. It's the color, I guess, of the text that you're putting in. Then we have the mask. The mask is kind of like the stencil or something if you're spray painting. So you put the stencil down, then you spray paint the source. And of course, the surface is what you're spray painting onto. Now, that said, what we had to do here is we had to get an array of all the different surfaces and all the different contexts. And then after having all of those, we then had to wrap all of this into its own vector so that we could do different layers. So we have 3 different layers. We have the background layer, the layer in which we draw all of the white lines, and then finally the layer in which all the dots appear. And we draw all the dots, then all of the lines, and it's kind of a pain in the butt. That said, it didn't turn out so badly, but we had to do everything ourselves. There are definitely some other ways to do this. I just don't know what they are. In terms of best scripting experience for animation, honestly, for 3D, Blender was the best I've seen. But that said, I haven't really looked very hard. And unfortunately, I don't know how to help looking for more. So I can look into it this afternoon, and maybe I can find a solution for you. Sorry about this, Zivo. I don't really have an answer now. But again, if you want to use Cairo, there's a lot of work here, and I can kind of help you see how to do that. But again, it's totally up to you. Let me see. That's Gustron. That's good to know. Gustron is a concurrent language. Good. Okay. So let's get back to it. What were we working on? We were working on adding the library size. So now let's go into vi huffman.h. And I apologize for the naming here. The naming here is quite bad. Now, what we're going to do is when we do the 2pass Huffman, where is 2pass Huffman? We should have that somewhere in here. Node, unordered map. Let's go down to 2pass. Oh, did I go into huffman.h again? I want huffman.cpp. Now we go into 2pass Huffman. Here we are. Next. There we are. Okay. Now what we're going to do is, since we are reading in, let's see, a string phrase, and we are returning back a Huffman tree, all we need to do is every time we get a new letter in the string phrase, we add it to let's see, what do we do here? We add it to add one to the library size. So how are we going to do that? Well, honestly, we already have the bitmap, right? And we have the size of the bitmap, and the bitmap should be the right size of the library. So how about we just do this? In fact, yeah, let's just do this. This is super easy. I tried SFML, and it can actually handle pretty good. Let me see. Just some simple game clones, Tetris, Snake. Yeah, so it's probably better than this one. But I thought it'd be overkill for a simpler visualization. We'll see. I don't know, maybe you can't go overkill for simple visualizations. Maybe, I don't know. I don't know how it goes. Have you ever tried fish shell? No, I have not. What is fish shell? So we have final tree and coded tree. And here's what I'm going to do. I'm going to say final tree dot alphabet size is going to be equal to, and in a sense, hey, million levels, in a sense, this particular variable is already given in our Huffman tree, but that's okay. That's okay. We'll worry about that in a second. So alphabet size is going to be equal to final tree dot bitmap dot size. Okay, let's add in a semicolon there. Right and quit. And now let's go over here and let's run the make command just to make sure I didn't do something stupid. So make command. And it's making the image one more time. Man, I am just losing my voice. By the way, guys, I don't know if you guys have ever, like, million levels, super new to programming. Let me see. Let's see. Super new to programming, by the way, so don't hurt me if I ask some stupid questions. Actually, please ask stupid questions. We have the tendency on this channel to accidentally go too far out of the working zone of people. So, like, you know, we're way far out, and all of a sudden we're talking about weird quantum physics-y things that don't make any sense to people who are new. So please ask as many questions as you can come up with. That's, I don't know, that's kind of the fun of streaming, right? You're programming, and people are generally curious about what you're programming. I don't know, I find it fun. Okay. Fish is pretty cool, but I seriously just like the POSIX incompatibility and handling of environmental variables. Yeah, I need to learn more about fish, apparently. Oh, actually, so yesterday, I went for a swim for the first time in ages in an actual laned pool. I usually just go out in the ocean, but I don't like ocean swimming because your water bottle is so far away, you really can't work out, you know? It's just kind of... Anyway, that's fine. While I was there was this old Japanese guy. He was like 80 years old, but he looked like he was 60 at most. Like, this guy was just... Man, he looked good for his age. And anyway, he stops us while we're swimming, rather when we're at the wall, and he says that, you know, I swim like a fish. And I was like, oh, I'm super glad. Because it'd been so long since I swam in a lane pool. I just felt like I'd lost all my ability. And turns out I have. Because I'm incredibly exhausted right now. My body is just like not moving appropriately. Okay, so Huffman visualization.cpp. This is what we're going to do next. We have the alphabet size. Now let's go down and give each of the... 1 second. Where are we? We're draw internal, draw tree. Let's go into the draw tree function and let's fix that one up. Okay, so if you remember, I think yesterday or maybe the day before, we fixed up the draw tree function to be a little bit simpler. Where's draw tree? Next. Here we are. So now it's just a recursive loop through, and if we get to a leaf, we draw the leaf, right? So the idea is that we're going through this entire tree that we see here, starting at the root node and going all the way down, and then when we find a leaf, we just put it out there. Now, the question is, where is that X position? Where are we putting the leaf? Million levels. How long have you been coding? Me personally, I learned to code when I was quite young, but I never learned how to code officially. Like, I never learned in a computer science class or something like that. I would say I have been coding pretty much every day for the past few years, maybe half a decade, so maybe 5 years. But I learned to code when I was like 14 or something like that. So I've known about coding for a while. Now, in terms of this particular project, it's been going off and on for the past week or so. Well, 2 weeks, but we took a week off, so about a week, something like that. Okay, so, and of course, if you have questions about how to learn to code, I mean, these guys can give you a lot of help. The people in chat are generally fantastic at programming, I would say. At least that's the impression they give off. So, Surely, if you ask a question, someone can answer. Okay. So, what are we going to do next? Now we have to give them an X position. So here what we're doing is we're reading in double X. But what I want to do, instead of reading in a double X, I want to change this up a little bit to int count. Count X. Yes, I have... so the determinant visualizations turned out pretty well, in my opinion. Actually, we can go ahead and show those. The one visualization I haven't done yet, because I've failed miserably at doing it, and I'll show you how I failed. Let's go ahead and CD into that real quick, just to kind of show you guys what it is. And it is C++. So let's CD into projects. I hope you guys don't think I'm being sidetracked, but this is, I think, kind of important. So we'll do visualization. Oh, we're already in visualization, so determinant. 1 second. Wait, where are we? Oh, no, we aren't in visualization. Visualization, determinant. Okay, so the other day we spent a while working on the determinant visualization. What is a determinant? And a lot of people, and I learned this actually like 2 days ago, a lot of people don't know that the determinant can very easily be said to be a ratio of the volumes. So you do a matrix transformation, and after the matrix transformation, you simply find the difference between the volumes, or the ratio between the volumes of the new transformed box and the old non-transformed box, and there you have it. You have the determinant. So let me go through and let me run mplayer angle 2.mp4, and I need to run vox11 so you guys can see it, and then I want to do loop 0. Okay, so I'm doing angle 2 because this is the one that you guys did not see on string. Oh, loop 0, sorry about that. And let me go ahead and run full screen. Okay, so let's go back and say what we're doing here. Okay, so we start with the box. This is just a random box in space. We do a transformation of the box till about here, and then we put the original box in. So now you can clearly see the original box has been transformed into the new box. In particular, you can clearly tell what the eigenvectors are. We have one vector that's stretching along this way, another vector that's stretching along this way, and another vector that's stretching along this way. So essentially we have one along the line y equals x, another along the line y equals negative x, and then one along the line of z. One along just z equals 1. And so we have stretching along those boxes. Then what we do is we put a giant box on the outside, and we perform Monte Carlo integration, which I think looks pretty good. We can modify the colors and stuff like that, but the entire animation looks something like this, and then we'll stop it at the very end here, and we'll kind of reverse back. So just to kind of show what's happening. We can of course increase the length, but this actually takes a good 30 minutes to make. I like it, but I understand, and the reason I put this up is if you guys don't like it, let me know how you might think to change it. One thing I don't like about this is the dots. I feel like we don't have enough dots to really make it Monte Carlo. We can add more dots, but it's going to take all day to render. So I'm going to try some more simulations here with more dots and so on and so forth. And we'll see how that goes. Of course, the other angle that we've seen before is this. Let me go to angle 1 and let's show that. So this is the angle that we've seen before, and it looks about as you might expect. Same general principle. And I think it turned out pretty well. Now there's one more visualization we need to do, and I'll talk about that in a second. Mostly bash automation. Let's see. Customer C++ and C API of the chirographics library for visualization. That was the last one I read. What type of programming do you usually do? For work, machine translation stuff. Cool, bash automation. So, do you go to college for computer science, programming, or something else? A lot of programmers that I've met are self-taught and didn't go to college. Really, that's interesting. So, million levels. Oh, yeah, I did physics as an undergraduate. However, I do, how do I put this? I do a lot of computational physics. So, I do a lot of work on our local computing cluster. Good. So, you have my respect. Split into library-based and very functional. But yeah. Okay. So those are the two visualizations I have right now. I have one last visualization I have to do. And let me just go ahead and show you guys how badly I failed at this one, just because I find it kind of funny. So let's CD into, I think, eigentest. Okay, so what I wanted to do, and you'll see, I think, immediately what I wanted to do and how I failed at this. So let me run blender -p eigentest.py. dot pi. Okay, this shouldn't render a movie, I don't think. Let's move this up here. Yeah, this is exactly what I wanted. Okay, so let's move this down here. Okay, so here's what I wanted to do. I wanted to create a whole bunch of lines in space. I wanted all of these lines to be of length 1. Let's zoom in a little bit. Then, as we went through, I wanted these lines to create a box. You'll notice that all of the Z positions are actually correct, right? So this is kind of the transformed box, but everything else is screwed up. Absolutely 100% screwed up. So I messed this one up big time. But it's not so bad. It's just me trying to figure out where to position the dots, because once we do a transformation, it shouldn't be that big of a deal. So hopefully we'll get this done the way we want to get it done. And we'll see how it goes. Okay, so let's go ahead and X out of that. Those are the simulations I've been doing for the determinant video. Now, back to Huffman. So let's go back. Sorry about the sidetrack, guys. I just thought it was kind of neat. Hopefully you guys weren't super angry at that. So let me run the last Mirage again. Or Mirage is my image viewer. What? Mirage. There we go. And here's our Huffman animation. Okay, so now we're going to read an int count x, and then what we're going to do is we're going to increment count x depending on how many count x's we have so far. So let's do it. So here's what we're going to say. OREX is going to be equal to count x divided by alphabet size. Now we can do this in a number of different ways. My best option here, because all we need is the alphabet size, instead of reading in the entire Huffman tree, we should read in just the alphabet size. So we're going to read in alphabet size here. And then what we do down here is we say count x plus 1. Count x plus 1. Plus equals 1. Good. Okay, so now we've read an alphabet size. This needs to be an integer. Integer. 1 second, I need some more water. Somehow I'm just losing my voice today. Good. Okay. Post it when you're done. Yeah. So actually, Edge has a pretty interesting project on his he does stream it a lot, I think. So it's, I think, pretty cool. Okay. So now what do you do? Draw a tree. Let's go up to the draw tree command. Jeez, I'm just I'm out of it. Every single day I am out of it. So let's go here. Animation resolution X. Do we read in the Huffman tree? We do not, it looks like. Frame animation node root. Unordered map char. So let's go ahead and also read in here. Alphabet size. Int. Alphabet size. Okay, and then we're going to go down here. Read in alphabet size. Oh no. We're going to have to bring it down to the next line. Okay, now what about the X position? Resolution X. Oh, this is also changing. So let's go down here and let's do 0. Good. Okay, so let's go down and let's see what we got. So regenerate nodes seems fine. Draw a tree seems fine. Let's go and fix those guys up at the very top. So let's do regenerate. Actually, let's go through all the draw tree functions first. Draw tree. And let's see, we have right here. Not necessary there. Next, draw tree. Good. We're already at the end here. So let's go ahead and put an int alphabet size. And let's go down here and say count, or int count x. So far I've made a really nice use of compilation system and really good, cool text library. Yeah, let's see. Okay, so what do we have here? Regenerate nodes. We also have to add in int alphabet size. 1 second. Int alphabet size. Okay, so what are we going to do next? Let's go down to main, and we should do regenerate. Yes, that's what we have. So let's go down here and do final tree. 1 second. Final tree dot alphabet. Gosh darn it. alphabet size. Okay, let's write this, go over here, and let's see what we got. So let's do, I don't know, let's write this. Oh, what am I doing? Undo whatever I just did. No, I want that. Write this. Now let's do make. It's gonna break. Yeah, of course it's gonna break. Let's do 329, which I suppose makes sense. 329. Okay, so since we had count plus equals 1 there, we can just read in count here. Then of course we have to read in alphabet size. So let's do count x. Down here, let's do count x. Count x. Let's move up here and change this to alphabet size. And let's go down here, change this also to alphabet size. 1 second, alphabet size. Okay, so now let's go ahead and write this, go over here, make it, and let's see what we got. Unused variables, that's fine. Okay, so let's see what it looks like. I've got a feeling all the nodes are going to be positioned incorrectly, but we'll see what happens. So Mirage animation.gif. We have them all being generated on the same X location. Oops, that's wrong. Okay, so let's see. Why would they all be generated at the same X location? We're reading in count X 0, but it should be that every time we go through, we increase the count X. Now, the thing is, we're clearly not increasing the count X. So, let me see. I've also wrapped it so random output. Yeah, okay. So let's see. What do we need to do? I thought this would be a little bit easier than what it apparently appears to be. So how about, let me think. We're going to be giving it, oh, you know what? Maybe this is the issue. Let's go here, and let's say it's going to be equal to count X. Let's say double. Count X divided by, why not double? Alphabet size. Let's go here, and let's make. And let's output the X position next time, when this one fails. And we'll see what the issue is. So, let's go into Mirage. Yeah, I figured that wasn't the issue. So let's go down here and let's do std. See out. What do we want? Let's do count X. And then we're also going to output, let's see, what's the next one? Ori.x. And line. Let's write this. I think the count's always 0. I think that's the issue that we have. So let's go to make. Let's see. Ori.x was not declared in the scope. Yes, of course not. It's root. Sorry about that. Pointing to Ori.x. No make. Let's see what we got. Okay, so it looks like we have X position of 1, 2, 3, 4, and they're at positions. Oh, okay. I know what I did. Let's multiply this by animation resolution X. Right, this. Now let's try making it one more time. In some sense, that's kind of what we're doing here. Gamertag Envy, what's up? How are you? Okay, so now we're going to turn this into an animation. Let's see what it looks like. Well, it looks like we're using the same X locations every time. Okay. Well, this isn't so bad. Let's see what we need to do. Okay. So it looks to me like all of them are being generated literally at the same X and Y locations. It looks like the further down the tree we go, the more likely we are to be in a particular slot. So again, what we need to do is find some sort of X position down here and increment the X positions. So we're going to go through, and let's see, we go through all the right nodes first. It doesn't matter which nodes we go through, that's fine. But because of how we're transversing this tree, it looks to me like we are pretty stuck here with how we've generated these nodes. So let's think about a new way to do it. It also has grammar pauses built in. Yeah, we did something quite similar a while ago, but that's okay. Witty Benz, I totally missed you coming in. My apologies. Thanks for coming in. Okay, I've been kind of off and on with chat today because a lot of it's between Edge and Gustorn, which is great. It's just that I haven't really been reading it as thoroughly as I probably should. My apologies. Zivo, do you recommend Introduction to Algorithms? Let me see. By Corman. I don't know because I have never read that book, so I don't know how to recommend it. I would recommend some book about algorithms, though. I don't know if that was answered directly in chat or not. Let's see. Anyone else that I miss, I apologize. Let's see. Edge226, very consistent. You have a new follower. Edge226, I might try it out later. Yeah, so, okay. If there's anything else that you guys need me to say, let me know. Just ask me the question. Start with my name, Simuleos. I'll see it in the in chat. Okay, so now how are we going to do this? We have count x. The problem is the following. Every time we go down the tree, we add 1 to the x position, right? But that's not exactly what we need to do here. So let's do something else instead. Let's give this guy an initial x position of, let me see here. Let's do alpha size divided by 2. Okay, gamertag, you haven't streamed in a while. Actually, I've been streaming somewhat consistently. Oh, or Edge226. I stream every day from 5 to 7 o'clock a.m. Japanese Standard Time. So, I apologize if maybe you've been missing my streams, but I totally stream consistently at this time of the day every day. Let height Huffman tree, then you can make a grid of dimensions. Leave circle size, 2 height, and you're guaranteed to have a space for the worst case scenario. Okay, so what do we have here? Count x. Let's not do this plus equals 1 here. Let's do it down here. So let's do count. If we're moving to the right, we're going to do count. 1 second. Yeah, sorry about that. So here's what we're going to do. Int count x, and this is going to be alpha size divided by 2. Should be okay. Now we're going to say count minus equals 1. And we're going to go up here and say count plus equals 1. 1 second. Count plus equals 1. Gusrun, I will try the idea in just a second. Let's go over here, and now let's make. Count was not declared in the scope. That's because it's count x. My apologies. And count x. Let's write this, go over here to make, and let's see what happens. Okay, so let's check the x locations real quick. Looks like maybe they're all in different locations. We'll see. Oh, it's okay, gamertag, no problem. Thanks for coming in. So let's do mirage animation.gif. Okay. Well, this is interesting. Huh. Not exactly sure what happened there. Okay, so we're starting at some particular count. That count is, apparently not what we want. So let me see. The count that we're reading in, it should be, let's say we have a alpha size of 13, right? If we have an alpha size of 13, yeah, I'm apparently not hitting all the cases. So if we have an alpha size of 26, then alpha size divided by 2 should be 13. If we go to the left, the next one should be, wait a minute, I see. This is different than what I wanted to do. So let me see, Gustroin. Let height of Huffman tree, then you can make grid of dimensions, leaf of circle size, times 2 raised to the height, leaf of circle size times height, and you're guaranteed to have space for the worst case scenario. I think, is that not kind of what we're doing right here? Maybe I am misinterpreting, but what I'm trying to do here is have a grid of x dimensions to start, which makes it so the y dimensions are automatically in a grid also, because it ends up being that the y positions are already in a grid based on the level, and then the x position is going to be in a grid based on how do I put it? 1 second. Wait, gamertag Envy, I'm an hour ahead of you. It is currently... Wait, you're here at 4:44 in the morning? That's crazy. Where is it 4:44 in the morning? Somewhere in Australia, maybe? I'm not sure. But if it is 4:44 in the morning, thanks for being here. Because that's super early in the morning. Oh, never mind. Never mind, I was wrong. Okay, so let's see. So if we start at 13, the next one should be here. Let's just work this out. Okay, let's go to page, New page before. The grid I'm proposing makes enough space for every leaf node, so they're guaranteed not to overlap. Yeah, the grid I'm proposing... I'm somewhat confused. Here, let's work this out. So the height of the Huffman tree, then you can make a grid of dimensions, leaf grid circle size. Okay. And you're guaranteed to have space for the worst case scenario. Yeah, let's see. So here's what I'm currently doing. And I think it's the same thing, is it not? So we have, let's see, leaf circle size, 2 times height, 2 raised to the height. Let me see. Wait, is height an integer? In your case, it's ht and int. So let me see. You're going to say... Here, let me go down here. Let me do z. Okay. The problem I'm having is I don't know how to place it onto the grid. You know what I'm saying? So the issue is that if we're on a leaf node, we want to place it in one of these initial positions, right? Which is fine. But I'm not sure how to get it onto that leaf node to begin with. So, here, let's draw one more. Why not? So if we're going down, I've tried to simply have like a count that we would increase. But maybe I increased the count at the wrong spot. Wait, let me try this again somewhere else. Would mindmap.com work for mind mapping? Instead, I don't know what mindmap.com is actually. So let's not do the count here. Let's not do the count here. Okay, let's do it down here. Grow circle. Let's see, where are we? We say root ori y. Root ori x is double count x divided by alphabet size. Okay. So, let me see. Let's go here, remove this line, and let's go down here. Oh, I see the problem. Okay. So the problem is, yeah, let's go here and let's change this variable to have an ampersand sign. And then let's see what happens. 1 second. Let me go to the top here. And let me do count. Oh, let me do the same thing here for draw tree. Okay. So now we're going to give this guy an ampersand sign. And let's go down to the bottom here. And let's do the following. Okay, so what we're going to do. Okay. Let's do count x. No. 1 second. We can remove this line, and let's take this line and bring it down to the bottom. Here. So we're going to bring this down here. 1 second. Animation current frame. Root left, root right. Grow circle. Okay. So we're going to give these guys an x, y location, where the x is equal to this, count x, and then we go down here and say count x. X plus equals 1. Add in a semicolon, write this. Now let's see what happens. Let's make it. Alphabet size divided by 2. Let me see. Invalid initialization of non-constant reference of type int from r value of type int. Okay. I didn't realize that was an issue. So let's go up here and let's see. Regenerate nodes, draw internal. What are we doing? Where are we calling this? We're calling it right here. So how about we just give it a definite size of 13. Just for now. Because I don't think it really matters that much. So let's go to make. Let me see. Invalid initialization of non-constant type reference. Here, let's change this actually to 0. Because I think that's what we want here. Invalid initialization of non-constant reference of type int. Let's go to 313. 313. Alphabet size. Wait, what? Of type int. I don't think I changed that one, did I? Frame animation, int alphabet size, count x. So write this, let's go over here to make. Invalid. From an r value of type int. What? Let me go up and see something. So let me go up to draw tree. Yes, draw tree. there, there, and here. Yeah, okay. So I'm not understanding exactly. Let's go to 313 one more time. What this is telling me. It's telling me that alphabet size, for some reason, is, I'm not allowed to use alphabet size in this way, and I'm not sure exactly why. Invalid initialization of non-constant reference of type int ampersand from an R value of type int. Let me think. So, what? Let me see. We have 0. It's okay with 0. Can I just read in? Let me just read in like a 26 or something like that. I don't know. Make. Yeah, so it doesn't like that either. Feel like I'm doing something majorly wrong here. Draw tree, frame animation, int count x. Maybe that's the issue? Huh. Oh, I see. I see. Let's create a variable up here, and let's say, I don't know, int count x equals 0. And let's just go up here and do count x. Right, go over here, make. Okay, that one worked just fine. Good. So now let's see where these guys are positioned. 1 second. Yeah, maybe more than a second. Okay, now let's do Mirage animation.gif. Okay, so these are all positioned at different locations. However, they are adding together in the wrong spot. That's fine. That's something we can fix in a bit. At this point, though, I'm kind of liking how this tree is turning out. So now we have to fix the drawing of the internal nodes. So let's go down there and fix that. And then this should solve most of our problems. So what are we going to do? Let's go to draw internal. Where is it? Draw internal. Okay, draw internal. So what are we doing here? Well, we're generating nodes.size is less than or greater than 0. We're going to do temp node regenerating nodes top, regenerating nodes pop. Okay, and then we say, are we on an internal node? If temp node key, then we animate line. I see. Okay. Okay, so let's think here. We animate line. What we need to do now is give these guys a position based on the following. So let's go down, regenerate nodes. Where are we? Draw tree. So let's go. We're going right, we're going left, and then we're checking the node that we're on, right? So we go right, we go left. Now what we need to do is say root origin y is going to be equal to this. But what we should really do is go down here and say, let's see, if there is no root right or root left, so then we say else. Let's see, because we've already updated the right and left, we should be able to do the following. And forgive me if I'm not able to do this, trees are not the thing I'm good at. So we're going to say root pointing to ori x is going to be equal to, and this is where things are a little bit weird, but I think this should work out just fine. We're going to say it's going to be equal to, let's say root pointing to left, pointing to ori.x plus root pointing to ori dot, oh, sorry, pointing to right, pointing to ori.x. Then we want to divide these by 2, so multiply by 0.5. And I need an extra parentheses in here. Okay, let's go ahead and write this. And now let's see what happens if we go over here and we make it. It's probably going to break, but that's okay. Broken code is my favorite type of code. So let's see what we got. It's 5:54 in the morning and it's making. Okay, so now let's do Mirage animation.gif. And let's see, we have all these guys positioned at some okay location and they're all adding together. Boom. Okay, that doesn't look so bad. Yeah, that doesn't look so bad at all. Good. I think it's a nice, readable tree. It's pretty good. I'm happy with that one. Okay, so now what we need to do is go down and work on one more thing. So let's clean up the draw tree command in here. Let's see, ori y, no matter what level we're on, is always going to be this. So that's okay to update ori y right there. So let's remove this guy. Remove this guy. Remove the dx's, because those are no longer needed in this iteration. Maybe I should have left one commented in. It's okay. It's okay. Remove this guy, that guy, and let's see, what else do we need? Now we need to change where OriX is in this location, or in this case. So it's not just animation.resolution_x, it is animation.resolution_x plus, 1 second, let me think here. We need to shift it over by just a very small amount. So how am I going to do that? I'm going to do that. I don't know yet. Let me think. So we need to add in a very small amount to OriX. So let's go down here. And I think, unless I'm incorrect here, which I could be, who knows, it's going to be animation.resolution_x divided by outfit size, size, and then we multiply this whole guy by 0.5. So let's do 0.5. So what we could have actually done is the following, and let's just do it this way. Add in a semicolon here, and let's add in a plus 0.5 here. Count x plus 0.5. And then I guess we are out of space, so let's... Okay, now we're not out of space. Okay, let's go here. Let's make it one more time. And let's see what we got. Okay. We have all these being generated. And hopefully none of the dots will be outside of the range that we want them to be in. So let's go to Mirage Image. It looks like... Oh, it looks like it's just a little bit over. Which is fine. Okay. But that said, it definitely looks more readable than the previous one we had before. None of the X locations are being overwritten, which is great. Now, the other thing too is the tree itself. Maybe that one could be done a little bit better, but I think it looks pretty good. This looks almost exactly like what I wanted, or what I would imagine a Huffman tree to look like. Now, the other thing too that we have to do is get these letters fixed, and a whole bunch of other things. So we've got a whole bunch of tidying up and things to work on. But it's looking pretty good so far. I'm pretty happy with how this is turning out. So if you guys have any questions or comments, let me know. I need a quick sip of water again because my voice is just gone today. I don't know why. I just cannot find it. So. Man, no. Now I have a drinking problem. Water is like all over me. Jeez. Okay. So let's see what we got here. We can draw this tree in a number of different ways. We can find ways to make, the drawing of it a little bit more, I guess you could say, pretty, but that comes later. Let's get some other stuff done first. Okay, so the next thing I want to do is play around with that different sizing for different levels thing that we did before. Except this time, instead of trying to do some sort of log2 thing, I want to just kind of start with a static size and drop it down from there. Hey, Mr. Sutherland, what's up? I feel like I haven't seen you in a while. Thanks for coming in. Okay, so let's go down and let's see what we need to do. Function, draw layers. No, I think I'm actually in the right spot. So, for example, if we use this guy, which we were using before, let's write this, let's go over here, and let's make it. You'll see we have a clear problem. Which could be fixed in a number of different ways. So let's see, what do we need to do? And of course, guys, if you have any suggestions, let me know. Gustorn, I guess, is drawing up a good suggestion, and we'll see what we need to do from there. Okay. So actually, this doesn't look so bad, except for the fact that it looks pretty bad. So let's see what we can do. I kind of like the difference in sizes here. I think it's kind of neat. But, let's see. Wait. Wakota des? Wakotsu des. Man, why does everyone know more Japanese than I do? Seriously, I live in Japan and I know like no Japanese. Yesterday, actually, when we went swimming, like, we went there and it was kind of hard because obviously they only knew Japanese and we only knew English, and we did our best to talk Japanese to them and they did their best to talk English to us, and I need to learn Japanese. I really need to learn Japanese. I hate being in Japan and not knowing Japanese. It's been a few months just tuning in, and we used Huffman trees for Huffman encoding in our algorithms and data structures class. In fact, we're going to be doing that in a little while. Go on Nico Nico? Huh. What is Nico Nico? I'll take a look at that in a bit. In fact, here, let me just Google it real quick. Nico Nico. Nico Nico video.jp. We'll see what's up. Okay. So, what do we need to do? Let's find a new way to do this. So instead of what we have right now, let's do the following. Then I left quickly. I realized it was stupid, then went back. I said that when I went to Tokyo, then I left quickly because I realized it was stupid. Then I went back. It only took me a year to learn the language. Yeah, I've been here for more than a year. Almost 2 years. Crap, and I don't even know, like, simple Japanese. Like, I have enough. I can go around, I can understand what people are saying, but speaking takes me forever. I can't get the words out. And so usually, like, when people are speaking, I can kind of sort of get the gist of what they're saying. But I don't know. We have some other problems in terms of me being able to speak to them. So what I'm going to do, I'm going to say we're going to be at 100 minus level. Let's go here. Oh, let's say level times 5. And let's do make. Hi, the Mad Dave. How are you? Okay. So repeat after me. Nope, I can't repeat after you. Too much kanji. That's how bad I am at Japanese. Yes, those are too big. You wanna know how I know they're too big? They're just too big. Okay, let's see. Let's do this a little bit differently. Let's do 35. Oh, that's a bad idea. Let's do 50. Okay, let's do make. The Mad Dave, if you have any questions, let me know. I'll totally answer them as soon as I see them in chat. Okay, so what do we need to do next? Let's look at the image one more time. Okay, Mirage image animation. That one looks better. Yeah, that one didn't look so bad. I mean, it doesn't look great, but it didn't look so bad. That was the point, but it's primary school kanji, so yeah, I'm sorry. Okay, so let's go here. What I'm gonna do is I'm actually gonna increase the X resolution a little bit. So let me go over to the top, and let's see, what do we want to do? Let's go to main, where we define the X stuff here, and instead of 400 by 300, let's do 800 by 600. Let's do make one more time. I meant as a tongue twister. What is Huffman Forest compared to a Huffman tree? A Huffman Forest is just a large number of Huffman trees. That's literally all it is. I'm not trying to, yeah, okay, Guster got it. I don't know. Sorry. Okay, so let's see what we got here. Man, I'm still sore. I gotta wake up my friend who went swimming with me tomorrow because we're supposed to work out at 7:05 every morning, but he never gets up. And so, oh gosh, this is gonna be a pain. It's supposed to be, wait, what is it today? I think chest day? Not sure. Okay, let's bring this over here. Okay. So we still have the general problem that we have some of the dots being cut off here over on the side. So we need to fix that. That's not a hard fix. We just multiply the entire scale by a little bit. Or we change this up a little bit. What we could do is we could give this a static size. And if we give it a static size, what do I mean by static size? I mean, instead of making the positions based on the resolution in X, which in this case is going to be 800, we give it a position in X dependent on the size of the radius, which is also fine. Okay, So let's go through, try this one more time. What I'm going to do, I have to say you have an entertaining programming stream. Oh, thanks, man. Usually it's just some music and typing code. Thanks, I appreciate that. Okay, so what's next? I don't know. Let's go through and let's change the resolution again to be 400 by 300. 400 by 300. And now let's go through and do something else. Yeah. Okay, so let's go down to where we're defining those positions of all the ball positions. No, ball sizes. I don't know. Guys, what do you think? Do you like... Yeah, you're right, you're right. Do you guys like the variable sizes? That's the question. I like them, but I'm not like sold on them. You know what I mean? On the one hand, sure, they look okay. On the other hand, what are they giving you? They're giving you weight information, right? Let me try something. So here's what we're going to do. We are going to give them a static size again. What am I doing? Draw tree. Let's go down here to draw tree. Here. Let's give them a static size one more time. And yeah, so let's give them the size of... Here, what I'm going to do is I'm just going to give them a size of 20. 10. I don't know. 7.5. Really, you think variable sizes are better than uneven levels? I kind of like the uneven levels. Let me go here to... Well, let's see what the uneven levels look like actually one more time. So let's go here. Let's do root pointing to ori.y is going to be equal to root pointing to weight. Oh, 1 second. Weight. Then we're going to divide by 127.0. Again, I just know what this number is, so I'm not so worried about it. Let's do make, and let's see what we got. You can actually see the difference with variable levels. With uneven levels, the whole thing just looks off. Let me see. Could I ask your PhD research topic? Yeah, so the Mad Dave, I actually work on something known as a Bose-Einstein condensate. The Bose-Einstein... Pretend that one didn't happen. The Bose-Einstein condensate is what's known as a superfluid. So the idea is that we take a whole bunch of bosons, we cool them down to absolute 0 Kelvin. This is all done theoretically, so I do a whole bunch of numerics and coding there. And then what we do is we just perturb the system in a number of different ways to mess around with vortices and things like that. It's actually really cool. But it's basically all just solving a single equation on a grid and then manipulating the grid around. Right now I'm working on GPU computing methods for that. You can actually see the difference in variable levels. With uneven levels, the whole thing looks off. Here, let's see. So let me go here. If you go to my channel, scroll down a little bit to my GitHub account. Let's go info, scroll down to github.com right here. You'll be brought to Simuleos. Again, it's a huge directory filled with a whole bunch of stuff, so navigate it by going to Huffman and then huffmanvisualization.cpp. This is the function that this is the code we're currently working on. So what are we going to do? Let's go to draw tree, and what I want to do is take this guy, and then we're just going to see what it looks like. Worst that happens, we don't like it, that's okay. So let's do this here, and let's remove that. Okay. You should put that in your description. Time to Google some. I could. However, the thing is, when I originally started streaming, I didn't really have an idea of what I was going to be doing. So let me do make. And so, I don't know. I feel like maybe it's not, I don't know. I don't know. Okay, so we're going to do 200. Let's see what it looks like. And now we're going to do mirage animation.gif. Okay, so here they all are. Yeah, I agree with you, Gustorn. That does look kind of weird. Yeah. Fair enough. The level thing does look better. Okay, so let's go here. Comment this guy out. Go here. And let's do it one more time. So make, and let's see what it looks like. Okay, so this is all with the static size. Now, we have to think about how we want to do a number of different things. So, let's say we want to increment the weight of a single node. That's something that we're going to have to run into, or we are going to run into in a bit. So let's see, what do we have here? Let's go to mirage animation.gif. Okay, and let me go through and see something. Okay, so now let's go through and do the same thing I was doing before with the change in weight. Okay, so how do I want to do this? What we need to do is have the X position somehow defined by the weight. So what I might do is just give these guys a standard, how do I put this? A standard, oh, what if we color them based on the weight? That'll come later. So let's give them a standard size of, let's say 10, and then let's add on, ooh, but the weight could go up to 127. Ooh, that's a lot of weight. What if we give them, ooh, gosh, this is not trivial, is it? How about weight divided by, no, let's do plus weight. So let's do root pointing to weight. The overlapping circles will happen in this case, but we can increase the X resolution to see what happens. So let's make this, and let's see what it looks like. So, 1 second. It's almost done, I promise. Okay, mirage-animation.gif. Honestly, that doesn't look awful. Let's do weight times 0.5. And let's, 1 second. Yeah, this should be okay, right? Let's remove this one for now, because this is based on level, we want to do based on weight. So now let's do make one more time, and let's see what this looks like. 1 second. And I don't know what to do. This has always been an issue on this stream. Every time I do something. Yeah, okay. It's not as obvious here. Here, this is what I'm going to do. Let's keep it just weight. And let's increase the X resolution to, I can probably put another 300 pixels in there, right? So let's add in, wait, 1 second, let me go to main. 400 by 300, let's add in 200 to this, so it'll be 600 by 450. Is that right? Yes. Go over here. Let's make, I don't know why I'm keeping a 4:3 resolution. We don't need to, I have been. Okay, take a little bit longer to make all the images, but not so much longer. But again, about putting my thesis stuff on the description, I think the reason I'm a little bit hesitant to do so is it's not that the work is proprietary at all, it's that it's unfinished. And though we have code available online, that is the code that I'm currently working on, I still feel like, I don't know, I feel like there's a little bit left to do. I feel like I don't necessarily want people to see it just yet. You know what I mean? Like, for academia, when you're publishing papers, you know, that's what matters, right? And that's something let me see. I would be willing to show people, but I don't know, I feel like, I don't know. I don't know if I'm comfortable putting my research stuff under the stream. Okay, so now I have to do one more thing. Let's go down here. And let's get that X position fixed a little bit better. So let me go to ori.x here, and let's multiply this entire guy by 0.9. Here. So now we're going to multiply this times 0.9. So we're shrinking it a little bit, and then we're adding in animation.resolution x times 0.5. Right, this. Go over here. Let's make it one more time. This is going to take some fiddling, but that's okay. We're just kind of shrinking it and putting it into the appropriate location. And the reason I want to do this is so that we don't have the balls being destroyed at the edge of the screen anymore, which is currently what's happening. I have a very pleasant experience with open source research, though. Like, after the paper was published, the authors made source code available. That was a blessing for me. Actually, the Mad Dave, we are currently doing that. Again, the code that we're working on is available, totally available, online, and you can take a look at it basically whenever you want. So, oops. I think I realized what I did wrong. Is this right? Let me think. So resolution X. Maybe it's right. Whatever. Let's try it. I don't know. I'm shot right now. Let's go here. Make. Yeah. So the code is actually freely available online, and I can give it to you. Hey, Fashta, what's up? Actually, in fact, here. Let me just give it to you right now. The code that I'm currently working on for research is let me see. Where would this be? It should be this one. So this is the code I'm currently working on. Most of my work is in the beta branch right now if you're interested in looking into it. But yeah, so that's the code I'm doing for research. Okay, so let me do mirage animation.gif and let's see what it looks like. How did I do it again? Come on. What am I doing? What am I doing? Okay, we're multiplying by 0.9. So whatever position we're at, we're shrinking the whole thing. Then afterwards, we shrink it down a little bit. And then we move it a little bit to the right, right? That makes sense. Am I doing this incorrectly? That totally makes sense. We're shrinking it, and then we're moving it a little bit. Why is this not working? Okay, let me see. Let's just multiply it by 0.9. Screw any of the shifting. Multiply by 0.9. Make. This should shrink it a little bit. Not that much, but a little bit. Okay. 1 second. It's doing its thing. And that's always the problem with this stream. There's always a moment when I'm in the middle of streaming. I'll show you in just a second once we show this guy up. The reason we want to do that is because these dots, this dot right here is being cut off. It's not actually for overlapping nodes this time. This time it's that we're cutting it off. So like, for example, if we don't have that 0.9 there, let's remove the 0.9, leave the semicolon, and let's go here to Mirage Animation. I think you should have 0.05. Yes, you're totally right. Oh, sorry. Let me make it again. Hey, That's Your Fan, what's up? Okay. And I guess chat? Yes, what's the question? We might be able to answer, we might not. Okay, so as this is making, I'll show you guys why we want to do the shrinking and moving once this is up. Okay, so let's see. Let's go to mirageanimation.gif. Okay, so you'll see this. Okay, let me scroll down. Okay, so here's the final tree. And you'll see that this guy's cut off and this guy's cut off. So we wanted to shrink it and go from there. Hey, Clone Style, what's up? Why are the earliest classes typically math classes? This is the best I can do right now. I'll take a look. Open link. When you say earliest classes... Oh, you're talking about earliest in the morning. Yeah, I noticed that too. Oh, wow, this looks really good, Gustorn. Let me see. Maximum number of children at level N... Let me see. The level is 0 based. You can divide the grid to 2H. Yeah, this looks fantastic. You haven't missed so much. We are drawing the Huffman tree right now. So let's see. You can lay out the tree using the same algorithm, but using integer grid XY coordinates. Yesterday, someone linked a solution to calculate left and right offsets based on children. You can combine that grid with the coordinates and reduce unnecessary padding. Let me see. You can divide the grid into 2 raised to the h times ht cells. Oh, I see what you mean now. Totally get it. Yeah. Okay, so then what we say... Yeah, okay. You're guaranteed no overlap with fixed size leaves. Yeah, I see what you're saying. Another off-the-topic question. Your rightmost window, is that some kind of IRC bridge? I'd love to know how you're displaying the Twitch chat in the console. What I'm doing is I'm using a program known as IRSSI. I'll type this into chat. IRSSI. It's an IRC client for your terminal. That's all there is to it. I log onto the Twitch, twitch.tv server. In fact, I might have done some sort of special thing, but I don't really remember what I did. So I apologize if there is some weird setup, but I'm sure you can Google it and find it. But IRSSI is what I'm currently using. Okay, so you're totally right, Gustorn. This The only problem I see with this one is that you have to have a dynamic, or not dynamic, you have to have like a statically sized box. But we can do this too. Oh, Twitch.tv has an IRC server. Kind of. It's like fake IRC. It's a little weird. There are some issues with it that were brought up a while ago by BPAF when he used to be here a lot. But that's how it goes. Let's see. Marion, thanks for coming in. Good morning. Or whatever time it is your time. Okay, so what are we going to do next? Let's go through. You need 0auth server key. It's easy to set up. Yeah, I guess so. It's a modified IRC chat. Yeah. Okay, so let's go here. If we dynamically change the sizes of these points, this becomes kind of harder to work with. So let me think here. I think it's so attention is not used up yet. Let's get this version of it working, and then we'll worry about it from there. Okay? Just making an executive decision. Let's get this working, and then we'll kind of figure out what we need to do from there. So what we need to do is multiply 0.85. That was meant to be 0. Okay. Then we have to add in plus, and it should be animation.resolution x times 0.15 divided by 2, so 0.725. Write this, go over here to this guy, and let's make it, and let's see what happens. Make. Okay, let's multiply it. Now let's go over here to make. Man, I feel like I keep doing something stupid. Now, let's think about that grid thing. In fact, I don't think we need to really worry about... So the next problem we have to solve is that overlapping problem, which is a problem that can be totally solved by that grid solution that Gustern posted. So let's take a look and think about that. So let's do this guy. Let's see what it looks like. Well, it's all there. So now we have to figure out this grid solution. Now, the grid solution can be solved just by increasing the X resolution, which is fine. In fact, because we have a statically sized image, that's kind of what we might want to do here, but there's more to it than just that, right? So the next thing that we might want to consider, on top of that 45-minute commute in the morning. Oh wait, what happened? I missed something. I think it's so. Oh, we're talking about the math classes. I'm terribly sorry. That's your fan. I've noticed that all of the mathematics courses in my previous university used to be at like 8 a.m., which was fine. I used to get up early, and I lived relatively close to campus. It was just a 20-minute commute, so it wasn't so bad. Of course, I lived in a trailer park, so I kind of had to get up a little bit earlier. So since it's likely the probabilities will be similar on the same level, you just adjust the grid height at every level. Yeah, I think we can. Okay. So let's think about how we want to do this. Is the bubble size dependent on the bubble depth? No, the bubble size is dependent on the weight of the node. So because this is Huffman encoding, the idea is that we have different weights that kind of work together, right? So what we're doing is we have a standard size, and that size is going to be a radius of here arbitrarily 10. And then what we do is we add the weight of each node to it. So for example, this guy up here, which is just a space, has the most used. It is the most used. So it's really, really big, but doesn't have a letter inside of it. Then the A and L are also quite used. So they're also quite big, but the T, exclamation point, period, and G are not used very often, so they're quite small. Let me go. So the, what am I doing? The circle size is 10 plus the root weight. You can keep the same size and change the intensity of the color. Yeah, we could do that too. Let me see, grow circle. So that was another thing we wanted to play with. Yeah, let's try that one. So instead of doing this plus root weight, let's see what happens if we change the color. Sorry, Gustorn, I feel really bad because you keep working on the changing thing. But let's see what happens if we change the color. I don't know. I like the change in sizes too, but let's just change the colors and see what's up. Okay. Dude, your code looks crazy. Did you learn coding in college? Snowy TP, I learned coding a long time ago, but I used it a lot in college, yeah. So, thanks for coming in, man. So, let's go here. Let's write this, go over here, make it one more time. So, this is what it looks like. Oh, what? Oh, of course. What? Wait, what? Oh, no, I forgot to freaking comment it. Okay, let's go here. Let's make it. Good. We didn't break it. So, what's next? So we have 200 frames. Let's take a look at what the animation looks like. 1 second. It's almost there. And then we'll go from there. Still converting. Nothing we can do until it's converted. Okay, now let's take a look at the animation. So to answer kind of some of you guys' questions that has been coming up, this is what it looks like if we do not dynamically size it based on the weight. You'll note that here it is very well spaced, right? So let's try color. In the end, I think we want to do a combination of the two based on weight. I want to change the size based on weight and also change the color, but it's good. We should probably change the color too. So what are we going to do here? Let's read in. You know, time dilation, man. I'm moving really, really quickly. So that's how it works. Oh, gosh. Did I really just make a relativity joke? Did anyone in the chat even get that? Probably. Let's see. Okay. Root key. What are we doing? Placing text in circle, grow circle. So in the grow circle command, let's read in the weight. So grow circle. Good, I'm glad. So let's just add in the weight, which we're going to say is... I'm trying to think here. The weight is going to be... We'll do normalized weight. That's fine. So let's do root weight. Pointing to weight. And let's just divide that by 127. I like the different sizes too. I think the different sizes is good. But let's also do this. So grow circle. I think the grow circle command is only used here. Yes. So let's go here and let's do double weight. Look at me. I totally know how to name things. Grow circle one more time. Update the whatever it's called. Grow circle here. Double weight. Same problem we ran into last time. Oh, what am I doing with my life? Go down here. Double weight. Okay, so now we're going to go up to the next grow circle command here. Now let's get the color. So before we statically set the color to be this green color, right? So what I want to do now is I want to go through and change the source a little bit. So let's see. How do I want to do this? We can do this in a number of different ways. I'm going to do it this way for now. So we're going to do... Let's see. We're just going to shift it from green to red, depending on this weight. Honestly, if we could go from green to yellow to red and have like the full spectrum of fall colors, that would be great. Actually, we can do that, can't we? I've done this before. Okay, so let's see. We know that the closer we are to the center, we want it to be yellow. Yellow is going to be green plus red, and we want to start at green. Okay, I've totally done this before. Let me think. How do we do this? Okay, so let's go in. Let's see if we can add in a color ramp. Adding in a color ramp. Okay. So, are you just you just use linear interpolation? Yeah, I'm trying to think here. Yeah, so we can dynamically change this. That's not so bad. Any significance in the order of the characters? The orders of the characters, no, there isn't really that much of a significance. We're just drawing all the letters right now. Or is it random A happened to be first? It is random that A happened to be first because the next one is an L or an I. I don't know if it's an L or a capital I. Jack and Jill went up the hill to fetch a pail of water. Jack fell down, broke his crown. Jill came tumbling after. Huh. Is there a capital I? There has to be. What else is this? Anyway, that's fine. The phrase we're using, by the way, if you're wondering why I just did that rhyme, the phrase that we're using is Jack and Jill went up the hill to fetch a pail of water. That's the phrase we're using. The whole shebang. Okay. So let's just do a simple color ramp just to make sure this is working, and then we'll do something a little bit more complicated from there. So starting with this color here, the next color we want to go to is, 1 second. I is next to the T to the right. It. Okay, so we want 1 to start. So it's going to be 1 times, let's do weight. So what's the... I think that's a capital I. So I think one is a lowercase l, and I think the other one's a capital I. This is lowercase I. No, I think it's capital I. I think we have capital and lowercase I. Wait, let me look at the phrase we're working with. 1 second. Let me go up to main. What do we have here? Jack and Jill. This is the phrase we're using. So, Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke his crown. Jill came tumbling after. That's the phrase we're using. It's a J? Oh, you're right. Maybe it is a J. Ha! Kyra can do HSV colors. I don't know. I have no idea. Let's just go through. I know I've done this before. Let's go to Grow Circle. And let's see what it looks like. So let's go down here and let's do a very simple color map. The exclamation mark. No, the exclamation mark's down here. I'm just going to leave this entire guy up. Why not? There we go. Okay. I think it is a J, actually. A capital J. And I think the text just isn't rendering appropriately. Let's lower the text size. Where do I define text size? Text. In circle, card text extends. That's not what I want. It should be an init. Init here. Where's text size? Font size. Sorry about that. Let's change this to 15. Let me go down to Grow Circle. Let's update that. And then let's see what happens. So, why not? We'll leave the animation up. That's fine. Okay, so let's go down here. Where's Grow Circle? Let's update this really quickly. So it's going to be, where are we? Here we are. Okay, 1 times 1 minus, wait. Okay, and it's going to be 0.25. That's what we wanted to start on. And we want to end it at 1. So how do we do this? 1 minus 1. Oh, I see what we want to do. 0.75. And we want this to be 0.25 plus 0.75 times weight. Let's write this. Now what we're going to do is go down to the draw tree. And let's see what happens. If we do this, and instead of reading in weight, we read in, where's Grow Circle? Root weight, 10. Oh, root weight divided by 127. Let's do root weight divided by 30. Okay, so now let's go over here to make. And let's see what happens. It's probably going to break. Holy crap, it didn't break. Okay, well, it's going to break when we show the animation. I'm sure something went wrong. Okay, so once it's up, we'll see what we need to do. And again, guys, if you have anything you want me to do with the animation, let me know. Because I can work on that as soon as I see it in chat. Okay, now let's see what it looks like. MirageAnimation.gif. All right, actually, that looks really cool. I just realized I changed the color the wrong way. But that's okay. It looks really cool. I like this difference in color. Yeah. Okay, let's try it again. And I can confirm that was a J. It's still a little bit... Okay, so let's go here. What do we want? Grow circle. Weight divided by 30 should be fine. Let's change it to red. So what are we going to do? Let's go to animate line, Cairo set source RGB. Yes, so... Thanks, Marianne. Okay, so let's go down here. And let's change the red. So 0.25 plus 0.75 times... 1 second. Wait. Right here, go over here, and let's make it. You could probably do green, yellow, red thing, but it's probably more trouble than it's worth. We'll see what happens. Thanks, the Mad Dave. So let's see what happens when this guy pops up. It should go from green to red, and we'll see what it looks like. Yeah, we'll see what it looks like. Man, okay, then we'll change the sizes too, and we'll see what that looks like. Hue interpolation, HSV, RGB conversion. I don't know. I don't know how to do anything with HSV. I don't think I've ever worked with it before. Okay. That brown color though. That brown color. I feel like I do want to change it to yellow at some point. Let me think. But the top one is a super bright red. I like that top one. It's kind of turning brown, which I guess is fair enough. That's what leaves do. They go from green to brown, but I like the blue one better. So let's see. What happens if we go from... Let's see. Let's change this around a little bit. In fact... Let me think. So how would we go... How would we go from green to yellow to red? That's a good question. Yes, that's one thing that I'd want to try. I guess it is kind of, but okay. How about this then? Let me go down. And let's say instead of weight divided by 30, let's see what happens if we change it to weight divided by 20. This should cause the coloring to happen more quickly. Right here, let's go over here, delete it, and then let's go to make, and let's see what happens. Okay, so once this is made, we'll then consider what we need to do to go from green to yellow to red, because hey, you know, I'm kind of enjoying just working with this right now, just kind of making random animations. It's kind of neat. And I think the better this looks, the more visually appealing it looks, I think the more interested we're going to get people into, you know, coding and stuff like that. Yeah, see, that doesn't look so bad. It looks a little bit better. Okay, so now let's think of something else. Let's go to, where are we? I wrote ramp or something, didn't I? Let me just go to grow circle. Okay. So we're down here, and let's see what we need to do. Adding color ramp. So again, I've done this before with Python. Let me think. So we want it to be... Why not? So here's what we're going to say. If... Wait. I'm sorry, guys. I know this is... I'm sorry. Okay, so if weight is less than super simple, 0.5, we do this. Else, oh, sorry, else, we do this. Okay, it's going to be basically the same command. So let's go ahead and copy that command here and here. Yeah, it's been a while, but that's okay. Okay, so what do we need to do? Cairo set source RGB, remove this guy. Move this guy up here. Cairo set source RGB, animation frame context. So the first one, we're going to go from green to yellow, right? So this is going to be from weight of 0 to weight 0.5. And what I want to do, actually, I want to output the weight at every point here. So let me do std cout weight. end line. Just so I know exactly where we're getting to, you know, because if we're getting all the way up to 1, that's great, but I want to see like what the distribution is here. Okay, so we want L. Oh, I guess I could do this in another way, but that's okay. So Cairo set source RGB. This one's going to be going from green to yellow. So this is what we're going to do. We're going to, I'm sorry guys, weight is going to be equal to weight times 2.0. Then we're going to go down here and say the following. So we want it from green to yellow. So let's see, this is adding in, we're starting with green, and then yellow. What is yellow? Yellow is a combination of additional reading. Good. I love more reading. Because of course, yep. Actually, this is quite useful. I should probably, oh, he has a Patreon. Wow, totally cool. Okay, anyway, that's fine. I'll look into this in a bit. Let me just do a very simple color scheme because we've got 20 minutes left. We can get this done there, and then we can worry about what we want to do. Yellow is equal to red plus green. Thanks, Dr. Kegel. Okay, so let's do, we want it to be 1.0 times 0.5 times the weight. And let me just pop this down here, just to make it a little bit easier to read, and change this guy to make it a little bit easier to read too. That's okay. We'll see what we can do with Cairo. I'm not sure what Cairo can do and what it can't yet. So frame context of I, 0.25 plus 75 times the weight. So we want it to go from green to yellow. So do we just increase red? Maybe that's all we need to do. Let's see what happens if we just increase red. Why not? Okay, so here we say weight is going to be equal to, so we're in the top half of the spectrum. So let's do weight minus 0.5 times 0.5. I'm sorry, 2.0. Now we've kind of taken this entire, it'll give each node a color that perfectly matches its weight, which would be fantastic. Okay, so animation frame context I. So let's start with yellow, which is going to be 1 red and 1 green. Okay, and let's go to red. So what we need to do is steadily remove the green. Minus 0.75 times the weight. Let's write this. And this is, in a way, you can go from green to red, and it will automatically include yellow in the middle. Really? I feel like... I'm not sure. I don't think it will. Let's go to make... okay. Give it a second. And let me check these weights while we're at it. It looks like some of these weights are super high. Let's see what this looks like. Give it a second to make the animation, and then we'll take a look at the animation. So let's go to animation.gif, and we have something crazy happening. Did anyone else just see that? What just happened? Is anyone else seeing this? I don't know what's happening, but this is clearly wrong. Huh. And anyone else seeing it? Am I just going crazy? Okay, they're starting out green, and then the colors are just flipping around. Huh. Okay, that's fine. It is definitely dynamic. This has nothing to do with quantum mechanics. Let me see, what's this? Linear interpolation between points. Is this what you just linked, Gustorn? Let me see. Yeah. So because we're changing just RGB instead of... I'm keeping this animation. I don't know what we did wrong, but I'm keeping this animation. This looks kind of silly. Okay, Let's take a look at those weights again. Huh. Okay, so the weights here, they get super high. And I'm not sure why they get so high. These are all 0. What? Let me output something. Up here we're going to say weight, but first we're going to say weight is. Weight is the following. Oh, that was an M. Right here, let's go over here and let's make it one more time. It's going to be different between LERP and color spaces. What does LERP mean, Gustorn? Sorry about that. I don't know. Okay, so now let's take a look at the weights. Weight is, those are all weights. Why are they all 0? Wait. Why are they all 0? That would mean... Oh. Okay, I think I know linear interpolation. Ah, thanks, man. Okay, so let's go frame by frame then. Mirage animation.gif. Let's zoom in a little bit. Okay, so they're all starting out yellow, and then they flicker between red and everything else. But it's weird. Huh. So like in this case, my first guess would be that what's happening here, Cairo has 3 different layers, as I've said before. So the top layer is the source. It's the color that you're reading in. Then you have the mask, which is the thing that you're drawing. In this case, we're drawing a whole bunch of circles. Then you have the surface, which is what you're drawing to. I thought that somehow the source is getting mixed up, but I don't know. I'm not really comfortable with this. I'm not comfortable with this at all. Because look, as we're drawing these lines, yeah, it's definitely something I'm keeping. I just don't know what it's doing. So here, this is what we're gonna do. We're gonna CP. We're gonna CP frames animation .gif into screwy .gif. That's just, we're keeping that one. I don't know what it did, but that's fine. So now we're gonna do. Gosh, what is happening? Yeah, the color should not change as we're drawing the lines. It should be that it's drawn once and then the color remains the same throughout. So let's go down to draw tree. Okay, when are we drawing these circles? We're drawing these circles here. Okay, so we're saying root, weight. Yeah, that's exactly the point. I don't know what it's doing asynchronously. So let's see, what do we have here? Ori X. The X positions are fine. Grow circle. This root weight that we're reading in somehow is screwing up. And it didn't screw up before. It only screwed up now. Okay. But the other thing to point out is every one of these circles... Oh, you know what? Here, let's do it this way. STD, cout, weight is... where are you drawing the lines? We're drawing the lines... Yeah, 1 second. Weight is weight and line. So the lines are being drawn here and draw internal. The idea is relatively easy. We're going through all of our generated nodes, which again is in a priority queue, kind of like what we've used before. And we're just taking the top node and we're drawing that top node. So at this point, all of the locations are already set. And all we're doing is animating the lines. The only thing that this is doing that is at all affecting the drawing of the leaves, so far as I'm aware, is that we are increasing the number, we're increasing the frame. So somehow we have a time dependence. And I'm not sure where that time dependence is coming from. And I'm also not sure why these are all settling on green and red. You see what I'm saying? Like, they're all just settling at some point. Meanwhile, before, they weren't settling. They were sticking to a color at some point. So if you remember, we had a clear gradient from like green to blue or something like that. Okay, so let's see. Instead of up here, animate line, grow circle. Instead of writing out the weight here, I'm going to write it out elsewhere. So let's go here, right? And let's go over here, remove this, and let's do make. weight. Oh, 351. Gosh darn it, 351. Weight is, and I need root weight. Make. Let's see what happens. Okay, so now we can go up and look at these weights. Weight is 10, 5, 3, 2, 1, 2, 4, 1, 1, 0. These should not be that high. Oh, yes, they should. Yeah, this is fine. So the highest weight is 24, which is that of the spaces. That's okay. Let's just go through and make sure it's normalized between 0 and 1, maybe? That shouldn't do anything, though. Okay, so let's make it one more time. This really shouldn't change anything but the final hue. And then let's go up to this guy. Grow a circle. Okay, so we changed the color here. For I less than number of frames, is the weight somehow changing? Wait, oh, the weight is changing. I know what, I did something really stupid here, guys. Really stupid. Okay, I know what happened. I know exactly what happened. Mirage animation.gif. Let me get out of this big loop here. Let's, kind of. Let me go here. Let me say double temp weight. Oh, that was a T, not an E. And let's go down here and say temp weight. Let me go down here and say temp weight. Okay, so let's multiply this by temp weight instead of weight. Let's go up here, multiply this by temp weight. Go over here, remove this, and let's make it. Give it a second to do its thing. Yes, this should be okay. Then we should go down to where we wrote weight is here. And we can comment this line out. I'm fairly certain we fixed it. Fairly certain. And I'll explain what the bug is, assuming that we fixed it. Oh man, that's me just failing miserably at life. Now we make it. Let's see what we got. Okay, this is kind of sort of what we want. So you can clearly see it's going from green to yellow and then red up here. But let's change this around a little bit. So it seems to me like we are more heavily... we're more heavily favoring red as opposed to yellow, which is fine because that's, I suppose, more physically correct here. But here's what I want to do, just so we can kind of get a prettier looking tree, which I know we probably shouldn't do, but that's okay. So weight of 0.25, and then we're going to multiply it by weight of 4. And then we're going to multiply this guy minus 0. Wait, what, let me think here. So, yeah, this should be okay. 2575 times the temp weight. Yeah. And then this guy should be, if it's greater than 0.75. Yeah, I know, right? So let me explain what's happening with those. What I was doing was, in order to make it easier to set the source to RGB, every time I was going through and changing the weight into something else. So I was doubling it or halving it or quadrupling it or something like that, which is why we had such crazy numbers for the weight as we were going down. So because the weight was constantly changing in the loop, we constantly had new colors every single time step. And that was what was happening. And then for some reason it just flickered back to green, and I'm not sure why that happened, but it was flickering. We kept the flickering animation though, so if you guys want, I can put that up on Twitter or something for you guys later. So temp weight, weight minus 0.5 times 2.0. Let me see, so if we're in the upper 25th percentile, or 75th, or I don't know what I just said there, but let's pretend I do. So what we want to do is, instead of subtracting 0.5, let's subtract 0.25, and then let's multiply this by, instead of 2.0, let's multiply it by, so we subtracted, so we want to multiply it by 4/3. So this is going to be 4 divided by 3, which should be a matter of 1.33. Sure, why not? Let's just go with it. Let's make it. And let's see how it's broken. Okay. And after this, guys, I think I'm going to commit it to GitHub, and then we'll see what needs to happen from there. So obviously there are some things that we still need to add in. And I want to try one more thing with the changing the size of the leaves again. And I want to see what that looks like. Mirage, animation.gif. So there we go. We have a more clear change from green to red. That's good. Okay, so now what do we need to do next? What we need to do, and let me add in another quick note here. Note, ramp is arbitrarily set. Okay, so what's next? What we need to do is change the size. Okay, so let's go down to grow circle. No, not grow circle, draw tree. And let's do, man, I'm just losing my voice. Draw tree. Here we are. Okay, so what we're gonna do is increase the size of these guys again, and let's see if it looks better or worse. Write this, go over here, delete that, and let's do make. And let's see what it looks like. I like it too. I think it looks really good. But we need to add in like a color ramp at the bottom and a lot of different things to finish it up. But it does look pretty good so far. So let's see what we got. 1 second. Still animating. Okay, so now we're gonna do Mirage frames animation.gif. Okay, so obviously we have some overlap, but assuming that we can fix the overlap, I don't know. I kind of still like the change in size here. I mean, again, we have overlapping nodes. That's something that we can probably fix. But let's make the change in weight a little bit less apparent here. So let's see, where are we doing this? Root weight. Let's do adding in root weight divided by. How about root weight? Let's do times 0.5. Let's go over here. Make it one more time. So it's less apparent than the change in size. Yeah, I like the changing in size. I really do. But again, we have to fix that overlap error. It's not really even an error. We just have to fix the overlap. And then we have a couple more things to do to make this animation really shine. And that we might have to do tomorrow because it's 6:58 in the morning. So let's take a look at what we have now. Yeah, okay. So these are kind of arbitrarily set, but I'm kind of liking it. It's a feature. Honestly, the way I see it, I don't mind the overlapping nodes. So long as you can read the characters on the inside, I'm fine with it. But I'm really liking this animation, guys. I think it looks pretty good. So we have the full fall spectrum here. Good. Okay. So I'm going to commit what we currently have to GitHub. We can work on it a little bit. If you guys have suggestions for how you want to work with this in the future, what we need to do, obviously Gustorn has the idea, or someone from yesterday, and Gustorn ran with the idea. Yeah, we can try a larger resolution. Let me commit this first, and then we'll try a larger resolution. And then we'll go from there. So let's see, what do we want? Git status, dot. It looks like we changed everything with Huffman in it. So let's do git add Huffman.cpp, Huffman.h, and Huffman visualization.cpp. Git commit. And what do I want to say? I'm going to say changed, let's say, X position. That was a C. Of external nodes. And added color. Right and quit. Git push origin master. Okay, so now we could make it flicker, but that isn't what it's not what we're here to do. We're here to visualize something that people can understand. Okay. So now, guys, you have access to this. It's on my stream. Here's my stream way up here. Just scroll down a little bit to my GitHub account, which is right somewhere there. Click on that. Go to Leos Simuleos, and then you'll have access in the Huffman directory, Simuleos Huffman, to all the changes we made today. So here are all the changes in case you are wondering. It doesn't look like we added so much, but hey, there was a lot of understanding there that we had to get through. So that's pretty cool. Okay, so let's try a larger resolution. Let's do vi huffman.cpp. And let's go down and increase the resolution. So let's go down to main. What do we have? We currently have 600 by 450. Let's make them rotate 360 degrees. Sure. I mean, it's going to be the same thing because they're a circle. Okay, so what was the resolution? 1920 by 1080? By 1080. And let's go down and increase the sizes too while we're at it. So let's see, where are we here? Count plus 005. I want to change it here. Wait. Oh, he means spinning. Not sure. So let's do make. Give it a second to make all the images, and we'll see what it looks like. Wait, so do you mean turning the whole tree? Like this? Oh, that's gonna be hard to do. I guess it's not impossible. No, we could do that. Yeah, we could totally do that. We could do that. But that'd take a little bit of thought on my part. Anyway, guys, it's about 7 o'clock. Once this animation is up, which, by the way, it won't make a very good animation because it's 1920 by 1080. So instead, I'm just going to show you guys all of the images from it, and then we'll go from there. One clockwise, one counterclockwise. Let's say the whole tree clockwise, and the leaves counterclockwise. I'm not sure what we're talking about here. So if are you talking about having like the leaves go this way, like kind of up around here, and then have the tree itself kind of turning and connecting to the leaves down here? I'm not sure. But guys, you have access to my code, so if you guys want to do anything with it, feel free to do so. If you guys can make like really cool trees, just make really cool trees. That's cool, you know? Since it's 7:02 and we're waiting for this to convert into an animation, I'm going to go ahead and let you guys know that if you are here for the first time, I stream from 5 to 7 o'clock a.m. Japanese Standard Time every single morning. Tomorrow we will continue working on the Huffman tree stuff. I haven't quite decided what we need to do because there's a lot of stuff left to do, but I don't know how I want to get it done. So there's a lot of little things here and there. At this point, though, I'm quite content with what it looks like. Now, what else do we need to say? Of course, if you're trying to find me or follow me or anything like that, I've got a YouTube channel. Feel free to follow me there too on Twitter if you're looking for other places that I am. Now, let's take a look at this larger animation. I'm just going to scroll down. In fact, let me do this. Let's close Mirage. Oh gosh, I screwed something up. Okay, now let's do image 0000. Okay, so let's scroll down. Okay, so 1920 by 1080 looks okay, but the points are kind of small. We could have increased the number of points. But that's about it. So you guys have access to my code. As always, feel free to mess with it, do whatever you want. We'll kind of take whatever tree looks the best. If you guys have some really cool visualization schemes or something that you want to work with, go ahead. I'm going to make a video on Huffman encoding, which should be up on my YouTube channel, not this upcoming weekend, but 2 weekends after that. So this upcoming weekend, I'm going to be doing the determinate visualization, which I think turned out fantastically. I'm really excited about that. And then the Huffman visualization will be up the next video after that. So we'll kind of go from there. As far as the future of this simulation goes, we still have to do the dynamic Huffman encoding, which is done with the Vitter algorithm, and let's see what we need to do. And I agree, Gustorn, I think it looks much better on a larger resolution. So before quitting, I'm going to go back up here to main, and I'm going to change this back to 600 by 450, just so that I don't accidentally make a huge image again. 600 to 450. And I'm just going to write it, and then we're going to call it a day. So again, you guys have access to the code. Feel free to do whatever you want with it. And I'll see you guys tomorrow for the next episode of Simuleos, where we continue working on the Huffman trees. Again, we might just go ahead and get started on the dynamic trees, which means less visualization, more programming, or we might continue with this and start working on the lettering and things like that, which still needs to be done. And I'm not sure how I want to get that one done. Lots of stuff to do there. In fact, what I might need to do is figure out some functions for the dynamic Huffman tree. Oh yeah, gust horn, that was super cool. I'm so happy with this. Larger resolution will definitely keep it from overlapping. But let me think, there's one more thing I wanted to say, which was, we have to do one more thing, which is, I don't know how to put this, but we have to find a way to dynamically increase the weight. And every time we increase the weight, we need to show the tree transforming based on the weight that we've added. And this is not going to be easy. I have to give it a lot of thought, and we have to figure out how to go from there. But that's okay. That's for another day. Maybe tomorrow, maybe in the future sometime. That's okay. Anyway, guys, at this point, I'd like to thank you so much for watching. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, where we again continue working on these trees, getting more stuff done. Thanks again for watching, and I guess I will see you next time. And yeah, maybe I can just rebuild the tree every time. Not sure. Alright, see you guys around.